Hello students, welcome to another episode of Concept Building. Today I'm going to introduce to you a very basic concept which is taught to you in class 5 or 6, and later when you grow a bit, then in class 8, class 9 and 10 you have to go through the numerical problems regarding all of these. Even students of class 9, if they do not have a very basic understanding of this particular concept, in different kinds of MCQ problems they do falter. Today we are going to learn the difference between mass and weight, which is a very preliminary topic taught in class 5, 6, mostly in class 6, and after that we are going to study a little bit of scalar and vector quantities. Since I am mostly focusing on students of ICSE and CBSE curriculum, I know you all have very little doubts in all of these, and now since the question papers are having MCQs, short type questions, long type questions, all of these they need a basic understanding. So let's proceed. So today we cover the preliminary concept of mass and weight. We know very well that when we go to a grocery shop and we ask the shopkeeper to give us certain thing, suppose you are being asked to bring 1 kilogram of sugar, okay? 1 kilogram of sugar is weighed with the help of a physical balance in a shop, okay? I think you all have noticed that. In that shop, many times we do a mistake in calling it the weight of that substance. What does that shopkeeper do? He puts some standard weight. Yes, he puts, that is what we say, but that is not what we actually measure. That we have to keep in mind. He puts the thing that you want from the shop, whatever, sugar, rice, potato, from the vegetable vendor. So whatever it is, he puts it there in either of the two pans. So suppose there is some standard weight that he puts here, and he puts whatever you are buying in a packet. Suppose that is sugar packet that he puts. Now the question is, many a time we make a mistake in saying that it is the weight of the substance. That's the basic mistake that we do, because though we know many things which are in everyday's life told, they are not the same as it should be told by physics, by knowing physics. Actually, with the help of this physical balance, we are measuring the mass of the substance. This is a physical balance that measures mass of the substance. Now, what is mass? Mass of the substance is the quantity of matter contained in that substance. So, what is it? It is the quantity of matter. Mass is the quantity of matter. Okay, this is the quantity of matter. Whatever you are going to buy or take, if we are talking about mass, then we have to say it is the quantity of matter in that substance. So, the mass of a substance, whether you are measuring at your home or you are measuring in the shop or you are taking that same thing and you are going to some hilly region to measure with the same physical balance, the mass of the substance does not change because the quantity of matter does not change. So basically, mass is related with the value of the matter inside that object. Whichever object we consider in life, in whichever thing, when we are measuring with the help of a physical balance, always remember you are not measuring the weight of that substance, you are measuring the mass of the substance, the quantity of matter. And quantity of matter does not change from place to place. The quantity of matter of any object does not change from place to place. Then what is weight? How do we differ it here? Now we come to know what is meant by weight of an object. The weight of an object is the force with which any object is attracted towards the earth. It is the force, I am repeating again, it is the force with which the earth attracts that object towards itself. Suppose I am having this pen cap in my hand and I leave it. Obviously, you know it will fall down. Why is it falling down? It is falling down due to earth's pull. It's known to everybody. Now, if it is being pulled by the earth, so some force acts on this pen. That means weight of an object is actually the force of pull. And what is this pull about? It's gravitational pull. Isn't it? And this weight of that object, is not going to remain same if you measure it at your home or you take it and go to the hill or the mountain, or you take it and go at the bottom of the ocean, or you take the same object to some other planet and measure its weight. It's well known to everybody that each and every planet has a different kind of pull on different kinds of objects. When you are having some apple on earth, whatever the apple will weigh on earth will be different if you take it to some other planet and then weigh it over there, because weight is actually the pull of that planet on that particular object, which varies. Keep in your mind that mass does not vary from place to place, but weight does vary. And how do you measure weight? You measure weight with the help of a spring balance. You see, I have tried to draw a spring balance. There is a spring inside this. In your school, if you are taken to the laboratory, I think your teacher is going to show you how the spring balance looks and how it works. This spring balance is having a spring inside here. Whatever weight you put or you attach with this hook is actually pulling the spring down. As the spring is being pulled down, here is a pointer. This pointer actually comes down or it goes up when this object is removed or the weight is lessened. This pointer will give you the weight of the object directly. The more the weight, the more the extension of the spring. This is known to you. So what we have is, here weight of an object is the force of pull on that particular object and it is measured with the spring balance. If you have the mass of the object as m, if I denote the mass of the object as m, then the weight of that same object will be given by m into g. The weight of the object is m into g. What is g? G is the acceleration due to gravity. At this preliminary stage in class 6, you have very little knowledge of acceleration, I know that. But I can give you a very small idea of acceleration. Suppose you have a small ball lying on the floor and you come and you kick the ball, okay, or you hit the ball with your hockey stick, okay. The ball initially was at rest, but when you strike the ball with the hockey stick or some other stick, the ball comes to motion. What does this mean? It means the object was not having any velocity. It was having velocity 0. But from there, when you hit the same ball, it came to motion having velocity v. So there is change of velocity. This change of velocity per unit time, that means the rate of change of velocity is called acceleration. So whenever there is a force on any object, the object has an acceleration. Now in the preliminary stage, I told you weight is also a force. So if you have an apple falling from a tree, if you have an apple falling from a tree, what does happen to this? It also experiences a force, pull, due to gravity. Yes, due to its gravitational pull. So that means force is acting. So if by application of a force, this ball has acceleration, acceleration means moving from certain velocity to certain velocity. It can be rest, it can be a change of velocity also. Suppose some object was having a less velocity and then after applying force on that object, it has a higher velocity. That means there is a change of velocity. Acceleration is nothing but change of velocity per unit time. Per unit time. Okay. So whenever here is an apple which is being pulled by gravity, the same apple is also going to have an acceleration. That means gradually its velocity will increase due to pull of gravity. Since this acceleration occurs due to gravity, that's why G is called acceleration due to gravity. Okay, this is called acceleration due to gravity. I think you have understood. The main thing to remember in this is that mass is something which does not change from place to place, but weight does change, because weight is force. It not only depends upon mass of the object, it also depends on acceleration due to gravity at that place. I think it is clear to you. And a very important thing to talk about is this mass has no direction. There is no directional property of mass. Whichever direction you want to take it, it will have the same mass, and there is no directional property for quantity of matter. It is just some amount of matter. It is just a quantity of matter. Some quantity cannot have direction. All right? But weight has a direction. And what is that direction? That direction is towards Earth. That means mass has no directional property. It has only some magnitude. Mass has only magnitude, no direction. But weight of an object, it has direction, it also has magnitude. So here comes a new idea that mass is a scalar quantity. Scalar quantity, and weight is a vector quantity. Let me tell you the definition in a very short manner. Scalar quantity is a quantity which has only magnitude and no direction, and vector quantity is a quantity which has both magnitude and direction. I think this topic discussed will give you a very clear idea of the differences between these two physical quantities and a preliminary but solidified idea of scalar and vector quantities, which you are going to learn in depth in higher classes. Thank you, students. I hope you are going to go through all these topics from your own syllabus, from your own book, and if you have any more queries, you can send it to me. Thank you.